we are going to create this mobile project, part of our framework. It will follow a lot the structure that we already created for the web. Initialize the Android driver here. You need to provide the URL to the server. Usually it's listening to the port 4.723. You can reuse the emulator and the app. This will optimize for sure the speed of the test, but again, it depends on your particular native application. And in our plugin, we need, like with the browser execution engine, we just put logic before the test initialize, because sometimes in the actual test initialize we want, for example, to navigate to a page. Some of these methods also, we have this super advanced switch to web view that accepts a function to filter which is the correct web view that we need. But before doing that, we need to take a closer look to the implementation of these fine strategies. Hi guys, greetings from Bulgaria. This will be our fourth video from the playlist about building advanced test automation frameworks. So let's begin. First, if you haven't subscribed to the channel, please do so, hit the ring bell so that you get notified when new videos are published, and they are published each week. Also check the awesome Lambda test blog, because there are so many advanced test automation articles and then can help you to be a much better test automation engineer. In the links below you will find the full source code, which is in GitHub. You need to clone the particular and check out the particular branch. In a minute I'm going to show you. Also you will find all relevant resources and jump links to particular sections from this video if you don't want to watch the whole video. Also I suggest to download and download the source code, and while I explain I suggest to check the code, right? Let's begin. I won't spend time on the course overview again, but we defined our requirements. We built basically the module for automating web, building these core components. Next, we upgraded our test automation library to be full-fledged framework in the previous module. I suggest to check and watch all the videos from this playlist one by one, because they're some kind of interconnected. And here in all of those videos about test automation frameworks, they basically upgrade our knowledge about design patterns. So if you haven't watched our course about design patterns, check it on the Lambda test channel. You will find the link below. So in this particular module, we are going to create this mobile project, part of our framework. It will follow a lot the structure that we already created for the web. So we're going to implement all of these core mobile classes. Of course, there is super many classes, and this is why I won't type the code manually so that we don't lose time, but I will walk you through the code. So let's begin. Again, I suggest to open the GitHub repo that you can find below. This is the repo Polaris-White test framework, and the branch that you need to clone is right here. This build core components for mobile. Again, for each of the modules out of this course, we have a different branch because we are upgrading the solution little by little, right? So I switch to this particular branch, and first, if you're not familiar with mobile test automation, I suggest to check. There is pretty awesome playlist on the Lambda Test YouTube channel about test automation with Appium. Of course, we're going to, upgrade your game here with this integration. Anyhow, like with the web tests, I have here some mobile test automation tests. We're going to use Android. Of course, I'm going to create the project only for Android, but it will be absolutely the same with iOS. The framework that I developed in the past called 𝑨𝒏𝒕𝒐𝒏, very advanced framework. We're using a very similar structure here, But yeah, we have two different projects. Instead of having just one called mobile, we can have Android and then another project for iOS. Some other frameworks that you can check that are open source, they actually combine them both. It's a matter of architecture, I guess. So here under demo tests project, where we had tests for web, we have a namespace for the mobile tests. As you can see, there are 5 files for now. I'm just going to run the test for very simple APM test, that is clicking, finding some elements in the normal, very popular demo Android demo app. I have set up here, I'm using an emulator, right? So this emulator is just a pretty standard emulator that comes with Visual Studio. I also used and I already started the APM desktop server. You can do it by command line, or you can use code. Here I commented this particular piece of code, which will basically start the server. That's it. And the way this works, let's run the test. Again, you can check the detailed playlist that you will find the links under the show notes. So now the project was built. In a second the application will start. The test, as you can see, is executing. As you can see, it's pretty straightforward. We're just opening a few pages, clicking buttons, and here there is a very nice view with some buttons and different types of elements, so like combo boxes, selects, checkboxes, radio buttons, text fields, etc. So in order this to work, we have AndroidDriver, of course, instead of 𝑖Web driver. When you initialize the AndroidDriver here, you need to provide the URL to the server. Usually it's listening to the port 4.723. I changed it to 22. And for the Android, we have a little bit more some settings, like the device name, which in my case is the emulator name. We have the platform name Android, the Android version, UI Automator 2. You will see in a second when we discuss why we need that. I have the test app path that later I will explain how it works. We have app package and the app activity, which is, you can think of it as the name of the specific screen that we're opening in Android. That's it. And of course, at the end, we need to dispose the driver. That's it. So let's see how we can upgrade that with our framework. In a similar fashion, let's see how this works when it's refactored. As you can see, I'm going to show you how we're going to make this work with a similar AppExecution plugin. The way we control the browser, this time we'll control the application itself. As you can see, we have much more settings here. We have the Android version, the device name, the app path, the app package. Of course, we don't want this to be copy-pasted every time, and in some of the next modules we're going to upgrade this solution to be able to put some of this default configuration inside configuration files, and this will allow us to have different configuration files for different test environments and setups. And also this will be greatly upgraded in the next module when we discuss responsive design testing and executing all of those tests on the real device in the Lambda Test Cloud. But more on that in the next module. For now, as you can see, we are here deriving from Android test, and also we have a very similar syntax that in a minute we are going to discuss again how this works. But similar to our web module out of our framework, we have this app class that gives us all of the different services like before, like app dot, as you can see, we have web, touch, elements, app service, devices. For example, in devices, this is a particular service that we can walk and walk and others. As you can guess from the elements, we can find the different components on the screen. What else? In the app service, we have so many methods like installing a different application, removing it, backgrounding application, switching to web views, and so on and so forth. And after that, the syntax for finding elements is very similar to what we had for the web module. We have different find methods here. Instead of just having one default one where we provide the by locators, instead we have our methods with the different locators, and we need, as a generic parameter, provide the different components here. We have button, checkboxes, radio buttons, and many others. And after that, we provide the different locators here as a parameter. Also, as part of our page objects, we can, using Fluent syntax, we have these extension methods for, we can chain them. By default, our framework will use lazy loading, which means that here at this line, our framework is not going to search for the element inside the application itself, but instead we'll do that internally at the moment when we do the first action. This is the lazy loading that we implemented in the web, and we're going to implement it here as well. And if you remember from the previous video about the web module, inside our web component adapter, we had logic where we use these wait strategies that are incorporated with these extension methods, and we had a list that we're for eaching them and waiting for all of these conditions. We're going to do absolutely the same. The whole reason for this particular architecture is that we strive always for the different modules, part of our framework, to follow the same architecture, the same syntax. This means that if you learn how to use the framework for web, and later you need to switch to mobile application, or later desktop application, or API testing, basically the syntax and the logic to be absolutely the same, of course with the differences between the technologies. So let's see how this works. I created this mobile project. As you can see, we have similar folder structure. We have assertions where you will see at the end of the module that we have similar validation methods. These validate methods, they basically allow us to wait for particular condition to happen. They will wait internally using Android mobile wait class. They will use it so that we wait for example, a button to become disabled, right? Also, inside the components, as we will discuss here, are all of the adapters that are wrapping the normal APM element and Android elements. We'll have different components for buttons, combo boxes, text fields, and all others. We'll use again strategy pattern for locators and wait strategies. We'll have services with different contracts. We'll have plugins again for controlling the application. So pretty similar architecture. However, there are some differences. Let's begin with, if you remember, we need a class, a factory for initializing the driver before working with the plugins, and this will be our driver factory here. So I'm going to first explain the driver factory. As you can see, later we're going to upgrade our solution to be thread safe. For now we don't need that. What does it mean to be thread safe? This means that at some point we will want our solution we want to execute our tests in parallel. This means that if we don't do some upgrades, there will be many consequences and problems. But we are going to use some thread local classes and others to make this work. So for now, we have a property marking whether this factory was disposed or not. We have app configuration class that it's initialized manually, or we're going to do it with our plugin. what we have here in the app configuration. Again, we'll refactor and remove these URLs later here. I added some to-dos for later modules. Why? Because basically this URL will, instead of being hard-coded here, we're going to change it through these configuration files, JSON configuration files. We have a few attributes. Again, if you remember, we have the browser. When you want to execute your tests in the mobile web browser, we need to pick a browser, right? Chrome, Firefox, or Edge. We have the execution type. For now, we don't care about that, but later in the next module, we're going to use this particular enumeration. For now, we're going to execute our test only locally on our emulator, or if you connect a real device, of course. We have the life cycle. In a minute, we're going to use it in our plugin, where we have a few options. Basically, you can reuse the emulator and the app. This will optimize for sure the speed of the test, but again, it depends on your particular native application. We can restart it every time, probably in the next module when we execute the test in the grid or in the Lambda test cloud. This is the suggested option, because otherwise you will just have one huge session with one really big video, and we don't want that. Or we can restart it on fail. We have the local execution attribute, similar to what we had for web. Again, we basically specified here that we want this attribute to be able to put it on top of a class, on top of a method. We don't want to be able to inherit it, and we don't allow multiple of those. We derive from the base class for all attributes the attribute, and as you can see, we have very similar properties like in our configuration. Basically, we have the app activity, app package, app path, browser name, device name. All of those we can set them through the attribute. And the app configuration, as you can guess from the name, this is a class, a model class for holding all of the settings that we need to control the execution of the application on our Android emulator or later real device. We need the app path, the life cycle, the device name, everything that we picked, and later we will allow the users of our framework to be able to add additional APM options. Like, for example, if you put a lock with a pin code, sometimes we need to add a specific option to allow users to override that. Or as you see in Lambda test the next time, there is a capability for bypassing the authentication with fingerprint, right? And we have a few constructors, nothing really special. But if we return to the DriverFactory, again, we have the app configuration, we have custom driver options. Again, later we'll use them. For now, we are going to ignore them. We have everything, as you notice, it's static. That's fine. For now, again, we're just going to run the test sequentially. Later, we're going to upgrade that. But we have a public property to the wrapped Android driver. And we have a factory method. If you remember this factory method design pattern, it's we use it to initialize some classes. And right now we use it to initialize the Android driver with particular configurations. The thing that we do is that right now, again, we support only local execution. This is why, again, later we're going to add more branching here. We are going to implement these cells here. For now, we have just the magic is happening here in the initialize driver regular mode or local mode, as you. Let's use the same terms every time. So from the app configuration, we get the URL again. If you use APM desktop, or if you started APM from the command line, this will be just your localhost on the default port. And we need to initialize these APM options. We set Android. I basically hard-coded those, but later we can move them to the configuration. We need the Android version, the device name again. Later we want to change that with the attribute, because basically sometimes it's like a requirement your application to support different Android versions and devices, of course. If it's a mobile web execution, we're going to set the default browser. Otherwise, we need to pick, as you can see here, we use app package, app activity, and app path. By default, for our demo project, I moved all of the applications here in the resources folder, right? And if you check properties, you will notice that I set them to be copied always. Basically, when you rebuild the application, they will be copied to the bin folder in this resource folder, and this is how I get them. However, it depends again if you have JSON configuration files later. It's a very common practice all of these solutions to be integrated in our continuous integration deployment process. This means that you have one build for example, building your application with particular settings. The output will be placed somewhere on your virtual machines for the build agents. Then you need to put this dynamic path supplied through environmental variables or something else. Again, this can be changed over time. For now, for simplicity, I just use this approach with copying the application there. After that, let's ignore these custom driver options. We initialize the driver, that's it, and we have a dispose method. This is how our DriverFactory works. Let's discuss now the plugin. If you remember from the previous module where we used the observer design pattern to extend in unit, our core methods for working with plugins, they're placed here inside our core project, right here, right? And we have the base class here that it's using this plugin execution engine. So this plugin execution engine, like with our web tests, we have this Android test that it's basically the base class for all Android tests. We have a property to the app class that later basically it exposes all properties to the different driver adapters, and we have methods for creating page objects. That's it. But the whole thing is that we have this configure method that we are overriding, where we added our app lifecycle plugin. This is how, instead of like here, instead of not here, but the no framework version, instead of repeating the whole code every time in the teardown and the setup, etc., the whole logic is happening inside our plugin here, app lifecycle plugin, this file. It works pretty much identical to how our browser lifecycle plugin was working. The name is different, of course. We, as you can see here, from all of the methods, again, we had different points, like before the class initialized and after the class initialized, before the test initialized, after the test initialized, before the test cleanup, after the test cleanup, before the class cleanup, after the test cleanup. We have 8 of those methods. However, since in our base class here we implemented all of them and their set is virtual but they are empty bodied, we can just override the ones that we need. And in our plugin we need, like with the browser execution engine, we just put logic before the test initialize, because sometimes in the actual test initialize we want, for example, to navigate to a page, or in this case we want to navigate to a particular activity or find elements. This is why we need to do that before the test initialize, and then after we execute the test cleanup, not before that, but after, because sometimes in the actual test cleanup we still do some actions in the application itself. This is why it's important to be after it. We basically are going to restart the app, close it, etc. So in before the actual test initialize here, we know right now which is the actual test that we're executing right now, and we use this get app configuration. Again, we use some reflection to get our vocal execution attribute on a class level and on a test level, and then from it we have a special method in our app configuration class that can initialize the app configuration from the attribute properties. And this is exactly what I do. Here we just have a simple branching for, you know, if you put something on the class, this means that the whole class will use this setting. However, you're allowed, like with the web tests, if you want to change something for a particular test, if you put this annotation here and, for example, change the Android version, this will be, if this is missing, we're going to use the class level. However, if we have it on a test level, then this will override the class level. Later, when we upgraded this plugin to use configurations, first we will have the configuration, then if you have a class, the class level will override the configuration, and then the third place will be the test, which will override both of them. So if we return to our plugin now, again, this is the branching here. For now, we have the app configuration, and after that, we just use the should restart method. It basically checks the life cycle, enumeration. If you set it that it needs to be restarted every time, then fine, we will restart the application every time. But as you can see, the restart app is just using our static driver factory. It will just close any existing connections to APM. It will close the app and then it will start it again. That's it. And we're going to shut it down. In the after test cleanup, we are doing very similar thing. We have two ifs. That basically, if we said that we want to restart it on failure and the actual outcome of the test is failure, then we're going to restart it. Otherwise, we have another condition for shutting it down. That's it. As you can see, it's very similar to what we had for the browser with slight differences. That's it. The biggest difference is that our app configuration actually have pretty much more configurations. That's it. So that was the plugins. That were the plugins. If we look into our services. Our services now, as you can see, I splitted the adapters again. We use here some partial classes. If you remember what a partial class is basically it allows us to split the class among many files, but when you build the project, all of those files, since they are partial, they will be combined in a single type. In this case, this will be the driver adapter. In this case, the driver adapter, instead of wrapping 𝑖WebDriver, we are wrapping AndroidDriver. However, since we want to support three types of applications on mobile devices, we want to support mobile web browsers, we want to support native applications for which we need AndroidDriver, but also we want to support hybrid applications, which are a mixture between the two. So you will need both the AndroidDriver, but also our web driver adapter. This is why if we open the project here and its dependencies, I reference here our Polaris White core project to be able to use the plugins in the base classes, but also I reference the web project because we are going to, for working with mobile web browsers and for working with hybrid applications and web views, we are going to use the already existing infrastructure in our web project. And I installed additional dependency to APM WebDriver, the latest version for now. If we return to our driver adapter, as you can see, nothing really special in the main class. We just have private variables and one public property that it's called wrapDriver that actually we get them, as you can see, from the DriverFactory. Again, at this point, when you need the driver adapter, we already executed the plugin. It's going to start and initialize the wrapped Android driver here. That's it. Now, for the rest of the driver adapters, if you remember how we use them in our app class, you will notice here that again I have a bunch of interfaces in this app class. We have a private variable to the driver adapter, and then instead of having access to the whole driver adapter, I have public properties to the element find service, device service, keyboard. Basically, I split the whole Android driver and I distributed it through these interfaces that we are going to see in a minute. And also we have page objects, or instead of calling them pages, which is wrong, I call them Android view. And if we take a closer look to the different services, you will notice that in the interface that I called app service, we have methods. I moved here all the methods that we control the application itself. We can activate it, background it, we can work with its context, we can install an application, remove it, switch to web views again, since the hybrid applications are a mixture between a native app and then they have this web view and working with web. This is why I put here in the app service the work with web views. Then we have the basically all the methods that we can work for the device. We can lock it, unlock it, we can turn on the location services, open notifications, set particular settings, rotate it, screen orientation, getting the device time, etc. I moved all of them here. We have a general interface that basically implements all of the rest. Then we have the element find service. In a minute I will return to it, but it exposes all of the methods that are responsible for locating our components. We have a few methods for working with files, downloading them from the device and saving them to the device. We have a few methods for working with the keyboard, hiding the keyboard and pressing some keys. We have touch actions. This is interesting, similar to the actions class in WebDriver, but here we have additional methods like swipe and tap that are specific to mobile devices. And also we have the web service. This web service, again, we use it in cases when we need to work with mobile web views in hybrid apps and with mobile web browsers. And instead of repeating the whole logic that we built in the web project, instead, of course, we are just referencing the web project. That's it. And here is the implementation. Again, this is a partial class, the driver adapter. We already have access to the Android driver that we initialized from the DriverFactory. And all of those files are implementing different interfaces. This particular file here, .app, is the same driver adapter. As you can see, there is a difference between the file name and the class name. It's implementing right now this particular interface. Again, the big benefit of doing that is that if you need to update something that is related to the file system, you don't need to search for it inside a very huge. If you had put everything inside one big file, it was going to be a hell to find what we need later if we need to do some changes. This is why I prefer this approach, at least in C#. So we implement this interface here. As you can see, sometimes we are catching some exceptions. With this start activity, sometimes it makes sense to hide the keyboard, because if the keyboard is there, this makes sometimes harder to find some elements. Besides that, we're just wrapping. These methods are not so interesting because we're just wrapping some of the regular actions that Android driver is doing. However, we're improving some of the signatures. As you can see right here, the default background is actually accepting time span, but most of the time, like 99% of the time, I think we'll just use seconds. And this is why we improved here the interface for our needs. We changed it, we adapted, and instead of providing time spans, which is a bit longer and longer to type, we just provide integers as seconds. And here, the interesting part, later when you clone the repo, you can check it out. Right now, this is not our priority, but I think it's a big improvement for have different methods for working with web views. Like half a year ago, I had to work on this complex hybrid application, and it was extremely hard to work with these web views. So as you can see, the regular syntax, to work with that, we need to do this type of casting. We need, sometimes in hybrid applications, we have many of these contexts, and you need to find the right one. For example, in Xamarin, this is the case. So yeah, so I moved here some of these methods. Also, we have this super advanced switch to web view that accepts a function to filter which is the correct web view that we need. So yeah, again, in the adapter, this is the whole purpose of using the adapter design pattern. We are adapting, we are making things simpler for the user instead of doing all those things every time. And regarding the device service implementation, as you can see, for example, here, the regular device time is returning string. I noticed that depending on the version of Android, depending on the particular mobile device that you use, the returned string is totally different, which doesn't work for me. I mean, when we want to assert that, we want to work with date time, for example. This is why I think we adapted that to return an actual datetime, and we format that, we parse it, etc. Also, what else? The rest of the methods here more or less are just wrapping the very similar methods in AndroidDriver. The same is for the files. Pretty much very similar for the hide keyboard, but I noticed that sometimes this is throwing an exception. This is why I decided to try catch it. Touch actions, this is interesting because we're using this actions class. However, there are some specifics about, for example, swiping. There isn't an original swipe here. This is why I simulated that with click and hold, then move to a second element. But again, you will notice that this method is generic. All of them are generic, and they are accepting our T component, which means that we're accepting our Android adapters, component adapters. This is our Android component. It's not the native Android element or APM element. This is why we need this adaptation right now. We have a similar thing for this swipe with coordinates. We have another implementation for the tap. Again, as you can see, we enrich. We make them a little bit. We provided more implementation here than it was, and we hided some complexity. And for this web service, we just exposed our WebDriver adapter here. Again, we are using all of the logic that we used before, all of the complexities of our web module. And before discussing the these find components, they are working in a very similar manner. But before doing that, we need to take a closer look to the implementation of these find strategies. More or less, they follow the same algorithm, the same design pattern like we use for the web. They're located here under the locator folder. However, they work in a slightly different manner because both drivers are different, right? So if we open here this find strategy, which is the base class for all of the find strategies, you will notice now that again we have the value, which is the actual XPath, the actual ID, the actual CSS, whatever. However, instead of having this convert method right now, we have different find elements for finding inside the application itself using the Android driver, or for searching inside an element. And as you can see, all of those methods are abstract, which means that for each particular strategy, which is ID containing or whatever, we need to implement that. If we take a closer look to one of the simplest ones, you will notice that right now we implemented all of those find methods, and we use the native approach for that, providing this mobile by the tag name, and we return the APM elements. That's it. And later inside our native find elements, we are using those for returning the original APM elements. That's it. The interesting part here is actually for most of my other strategies, for example, for ID find strategy. Since we are using UI Automator, with my experience, I noticed that when you have the mobile application and when you open it, APM sometimes struggle to find elements that are not visible on the screen. You need to scroll down, swipe to the bottom until the element is visible, and this is very hard to do. This is why there is a very secret and strange way of how to do that. If you use Android UI Automator locators, and in them there is a native way in Android. If you wrap this UI selector inside the UI scrollable, and they have a native method called scroll into view, then you need to pass another UI selector, and then we use this resource ID, which is the native way how we locate elements with UI Automator. How I found that? There are a few advanced articles that you can find online for doing that. However, the best way to check all of those is if you open developer.android.com here, and there is a reference for UI Automator. All of those are described here. And as you can see here, from the right there is an agenda with all of the methods, and here we have resource ID matches, which is using regular expressions to find elements. Again, this is super complex, very easy to make a mistake. This is why strategy pattern here is super excellent, because we are going to reuse it every time. But again, this is super magic, because every time when you provide this selector, we are just going to provide the actual ID, but we are going to use string interpolation to generate this out of the box for us. Natively, it will use, instead of using mobile by.id, we are going to use every time Android UI Automator. And then this automatically will scroll down, and then we'll find the element by ID, which is super awesome, right? And I did a very similar thing for example, ID containing, but this time here we use resource ID matches, which again is using regular expressions. For some of them, I left them for you just to see. If you don't want this more complex approach, you can just use the standard way of doing that with the native elements. That's it. If we need to discuss the other type of strategies, the weight strategies, you already saw in our tests that we're using the framework. We already have the capability of, if you remember from the web part, we have this to be clickable, then to be visible, and we can chain as many of those as we like. If we open that, you will see that we have this class Android component extensions. It's extending our Android component adapter that we are going to discuss in a minute. But basically, this is just calling the component ensure state, which is adding these strategies to the list with strategies that we're going to for each inside our lazy loading. And we're going to execute its method wait until for waiting for the element to be clickable, to be visible, to exist, etc. Again, you can find all of those strategies inside this folder. They're following the same pattern as before. If we open the base class for them, this wait strategy, we are just getting the route driver, we have the timeout, the sleep, we have an abstract method that all the strategies need to implement, and basically that's it. Instead of WebDriver wait, you're using the native AndroidDriver wait. That's it. And if we take if we see how the toExist wait strategy works, we just derive from the base strategy. We have a constructor. We implemented this wait until that accepts find strategy, and that accepts this function that returns a boolean that accepts the AndroidDriver and the find strategy as a generic, and we're waiting for this element not to be known. Absolutely the same way they're working as our web, so we're not going to spend more time here. However, we need again to discuss first, before we walk into the find methods, we need to look how our Android adapter component is working. Again, the adapter is using composition to wrap the original APM element, and we are implementing here lazy loading, which means that at the moment when we find the element here, at this moment we are just creating an instance for the button, but we are not finding the native APM element. We are doing that inside this click, and let me show you how this works again. We have a few properties here. We have an access to the parent wrapped element. We have the find strategy, which is super important for our for our component adapter, right? We know the elements now, the components, they know all of them, the button, the checkbox, the combo box, all of them, they know how they were located, holding a reference to their find strategy. Then we have access to the wrap driver, and we have also a list to all the strategies. At the moment when we call find, this will just initialize the list, the driver adapters, that's it. We'll just get an instance, a reference to the wrap driver through the DriverFactory. And then the whole magic again is happening inside this wrap element property, triggering the lazy loading. And as you can see here, all of the public properties, or the protected ones, they're calling the wrapped element, which means that, as you can see, by default we're checking, is this wrapped element, which by default is no because we are not initializing it in the constructor. If it's no, then we are going to find it and we're going to call the native find element. Otherwise, we're going to return it, right? This is how the lazy loading works. And this find element, it accepts our find strategy. Then it checks if our list with wait strategies, if it's empty, then we're going to add to it toExist wait strategy. This means that every time we will be sure we will wait until the element exists on the screen. If we have more, and if we have changed this to be visible, to be clickable, to exist, etc., we're going to for each them, we're going to wait for all of them to happen, and just right then we're going to call this native element where we're going to search with the find strategy. This is the moment when we execute our strategy. If you remember, every strategy has 4 implementations of searching inside the app using the native wrap driver, or searching inside inside the wrapped element. That's it. This is how the magic works. Also, we have here all of the different find methods, but again, they are searching instead of inside the driver, we are looking inside the parent wrapped element. That's it. But all of the rest of the methods here, like get size, get location, hover, we are working with the wrapped element. This is how the lazy working is working. And the rest of the components, they are just deriving again from this base component adapter, the Android driver, and we are implementing some of the interfaces. If you remember, at the end we are going to discuss that, but we need them in order to have access to these validate methods that will wait for element to be disabled, to have a particular text, etc. And as you can see, we have different components: the button, checkbox, combo box, image, label, number, password. They're significantly simpler if we compare them with the web, because here you don't have so many attributes, right? And the actual possibility that you can do with Android driver, you're limited, right? Even you're more limited with iOS driver, but yeah. For example, as I said, these adapters, they can help you to simplify the usage, right? Like with the get number, we're getting the text, then it depends how this works, but for example, this number, it has an inner Android element, so this is why I'm finding it with class name, then we parse the number, then we return it as an integer. For the button, for example, we use type text. However, if we take a closer look, and if you remember how this works, I put some of the common methods inside my Android component, the component adapter, but they are marked as protected, since we don't want to allow, for example, it doesn't make sense to type text inside an image, right? Or it doesn't make sense to have access to type text inside the label or a combo box. It depends on the combo box, but still, this is why they're protected. This means if you explicitly doesn't use the keyword new, you won't have access to them, and this is why I predefine the type text method. I use the keyword new, and then I call the base implementation using the base keyword. If I have something new, like for example in the checkbox, this is, I don't have it inside my Android component because I need it only here. I tried in all of the components to have the same naming, the same signature, similar to the web. For example, if we later add a similar module for working with Winamp driver for desktop, I will try to do absolutely the same, to have the similar architecture, the similar names of the methods, similar signatures, as long as it's possible, right? So I will return in a minute here to these components. I will just quickly explain again how these find methods work. Again, they're generic methods. This T component means that I can supply here all of these different types, even if you define them in your custom project. I can put here any component that it's deriving and has a base class, this Android component. I mentioned here the keyword new, this generic constraint, and this means that all of my components, they have an empty constructor. And if you remember, in my empty constructor, I'm just initializing the wrap driver and the list with strategies. And then we initialize here the correct find strategy. In this case, this is the ID. In this case, this is ID containing. And the whole magic is happening inside these two methods, where I accept a find strategy. Then we create, since we are sure with this constraint that this T component has an empty constructor, we call the native the empty constructor, we initialize the find strategy, we initialize the route driver, we return the component. But at this moment, if you remember the Android component here and its empty constructor, we are not calling anywhere finding of the elements. This is the big deal about the lazy loading. And lastly, if you remember, if we return to our framework version, here I have these validate methods. They are super specific regarding, for example, here I will have is visible, inner text, etc. However, if I change that to another type, imagine that this is a checkbox. And if I call, as you can see, the checkbox doesn't have a method click, which is logical. And if I call validate, now I have validate is checked, which I didn't have for my button, right? And the way this works is, again, we have these interfaces. I haven't implemented all of them, I haven't created all of them, but if you remember, we'll have disabled no matter what you want to validate, right? So for example, for the button, we have interfaces for 𝑖Disabled and 𝑖Text. For the checkbox now, I have disabled, checked, and text. And the way this works is that this checked interface, it means that I need to have a property here implemented for isChecked. And inside this assertions folder, I have these validate component extensions. The way this works is that I have all of those extension methods because they're basically put it inside the static class. These are static methods. We use this special syntax for the extension methods here with the this keyword. They're all of them. Right now, as you can see, T or T component is not the actual component. We are not mentioning that right now we need to derive from the Android component adapter, but instead I'm extending the interface itself. This means that all of the components that are implementing this particular interface, they will have access to these extension methods. And normally, as before, this validate method internally is using WebDriver wait, and it will wait until this condition is true for a particular amount of time, whether it's visible, whether it's checked, and we're going to throw a specific exception with this particular message here. This is another cool thing here with this particular message, and we can override the timeout, because sometimes you may by default wait for 20 seconds, but in particular cases that you know that your application is slow, you can put longer timeouts. Yeah, that's it. As you can see, we covered all of it. The whole structure is pretty similar. It has some differences because of the specific of Appium, but right now we have two modules, web and mobile, that they follow a very similar structure, which is pretty awesome. We implemented again the adapter design pattern, the observer, we use strategies, we use factory methods, tons of design patterns. You can find in the links below the links to the playlist with design patterns. If you haven't watched this, I suggest to check it out. Also, if you're not familiar with NUnit, you will find a link to this playlist as well. Yeah, in the next module, we are going to cover responsive design testing, which will be a very important module where we are going to upgrade what we currently have to support execution in the grid, to support execution in the cloud. We'll add more settings in our attributes so that we can, for example, change the size of the application. We'll add some additional assertions to check and assert the layouts. We'll have these layout assertions. For the web, we will have these style assertions. Many exciting things, so check it out. So if you have any questions, put them in the comments below. Also, again, check the Lambda test blog because there are many awesome articles, and get your free certification about NUnit, Selenium, Appium, and many other technologies. Thank you for watching, and see you in the next module.